Oops, don't do that. Just sitting over here reading the shader code on like LCD monitor rendering, like LCD anti-aliasing with the colors. I'll have to figure out what I've never done a situation where you have two source outputs or two output colors that you then blend in the output function. I've never messed with that before, so I have to look at what GL source 1 does at some point. But for now, we don't have to do that. I'm just taking a peek. Alright, so this is where we're at now. I can create input via scripts, and that input processing system, or rather I should say, the file enumeration is working on Linux, so it also generates the tests correctly. It doesn't actually take input tests yet. That's something separate I haven't done. But we're that far along now. Do I still want to do record actual input? Or do I want to organize a test folder? Organize a test folder, record actual input. Organize a test folder, record actual input. Recording test input, or recording actual input will involve reading out from the input struct at each step the events that I think have happened and emitting those events into like some kind of buffer or whatever, and then upon closing, saving that buffer. Or possibly I'll control it in a way that doesn't force me to close in order to save the events into a file. Like if I somehow was able to do begin recording, whenever I say begin recording events, oh, excuse me, I'll have to send that data back to the platform layer. It's kind of a pain. Um, but it's not that big a deal. I'd probably start with the one where I don't control it, because that's the easier one to implement, and then I can switch to a method where I do control it. So I figure I'll just pass a flag that's like record, and then it'll record everything I do that session, and it will output those simulation events. And then I can go through those simulation events well, or what I rather mean to say is then I can just play those simulation events back, or I can include them into other simulations with the script system. Then the only question is it very hard to extract events from the finished input struct? Because a part of what happens is we have the input struct that we're actually passing in, and then we have simulation events that happen that change the state of the input struct. So I would have to be able to, from an input struct, after all the data has been collected on Windows, look at the input struct and reverse engineer the events that happened. The kind of events that can happen. So the debug numbers wouldn't get output at all. Key presses would not be hard to find. Left press, left release, none of those would be hard to find. Wheel would not be hard to find. The mouse XY would only be difficult in the sense that it would be difficult in the sense that you have to track the previous XY and the current XY every frame to see if a move of the mouse has happened. But besides that, it's not that big a deal. And exits are just a boolean. Yeah, this is not that bad. We can do this pretty straightforwardly. Now, it actually kind of raises the question, do I really want to do this on the platform level, or would it be better for this to be entirely contained at the core, inside the core? Because then it would automatically work on every platform, and if I can reverse engineer all of the information right out of the input struct that I've been passing into the core, it's not clear why I would do it on the outside of the core where I'm going to end up triplicating the code. I should put it inside the core. Except the one problem with that is how much easier it is to create the file handle and write stuff out when it's outside the main loop. On the other hand, on Mac that wouldn't be any easier, in fact be harder, because you'd have to do the craziness that you were going to have to do anyway, plus you would have to do it in a framework that wasn't one you owned and controlled and understood. So I'm going to do it inside the core. So now the next question is, how do I want to actually control the lifespan of when I begin recording, when I end recording, and so on, right? And so I get called every frame. On init, I can just begin the recording. How will I handle running out of memory? I'll just call directly to the operating system's call. This is like a debug feature anyway. So it'll just call right to the low-level thing that gives me more memory. I won't put it in any of the live data structures. And like the normal data structures that would be there even if I didn't have this flag set. And we'll close, we'll save the data into a file when we know that we're returning that we want to exit, is what we'll do. We could also save it every single frame so that we're not able to lose the input simulation, which would have the added benefit of starting to test out how feasible it is to do like an autosaved thing, like eliminating the Control S. which is something people have wanted, which I'm not going to do for like right away, but hey, maybe I start playing with it and see if it's something we can manage. And we only, in the future, will want to save edited buffers anyway, so we could do something that's like save every time we know that there's at least one new event on the queue. How do we ever put an exit event on the queue? And for that matter, do exit events necessarily force the system to quit? I don't think they do. Now I'm just thinking to myself, did I ever actually test this situation? Type the hello. What? The process cannot access this file. What? Okay, there we go. By the way, you can go away. Yeah, go ahead. And now I'm going to run that test. No, that didn't work. Interesting. So can you slow this down? Give me 5 frames on each of these. And 20 on each of these. Jack of Sporks asks, now beta engine? No, I'm not making the beta engine yet. I'm retiring the alpha engine, as in I'm settling it down. I'm still working on the alpha engine, putting it into a sort of final state. The beta engine's been happening in the background for a while now. That's still too fast. I didn't rebuild the test. Alright. Unicode. Ah, okay. So when I do that, I need to like wait 10. Yeah, today we're working on testing and stabilizing the alpha stuff enough so that people who are relying on it will be okay while I don't make any more updates. I don't understand why that isn't opening the file. Boom, boom. Unicode.txt. Ah, there it goes. Alright, so it's because I was pressing new line in the same frame when I pressed the H, or No, at the same time when I press the T on txt. Oh, if this wasn't here, we would have a problem. No, that worked. What about this? If this wasn't here, would we have a problem? Also, this is still going by way too fast. I can't tell if it's doing the exit thing or not. Okay, it's doing the exit thing. Why did it not? Oh, so that time it is this one that matters. Oh, hello. And if I take it out, I get ELO, don't I? ELLO. The H is getting put on the line before. Okay, let's see. Enter. Yeah, TXTH, LO. Okay. Okay, wow. So there we go. That was catching a bug. Nice. But the point of this is now I can see that when I exit, it doesn't necessarily quit, which makes me question everything. In particular, it makes me question whether it was a good idea to do that stuff I did with the invoke command. I'm going to go change that. No, test builder. I'm going to say if there's an exit in there, just respect the exit, because an exit is actually not... it's so hard to say. If I don't respect the exit, then right, if I do what I was doing, then I can invoke things that have exits in them that would normally cause it to close and just say no, ignore that. But if I want to ever test the exit, what I really need is two different invoke types, right? One way to invoke a thing that's like raw that doesn't make this change, and one that is non-raw that does make this change. So like I have the one that does make this change. Invoke and not invoke raw data, then do that. Invoke raw data equals false. Where's invoke? There we go. So I'm going to call this a raw invoke, and then invoke raw data can be true. Okay. That seems good enough to me. So now what we want to look at is building these, grabbing input, recording input. That's what I'm talking about in the core. Later. All right. So let's see. Let's do overhead CPP. All right. App step. All right. Okay, so here's how I want this to work. App step init, or really let's start with the command line. Yeah, let's find where app settings is defined. And record, make input recording, char star input recording output file. And then we're going to take both of those back here to where we actually init command line settings, and we're going to add case R action CL act record input boop, boop, test input. Alright, so for recording input, I is less than argc, and then action equals nothing. Then settings, make input recording equals true, settings, input recording output file equals argvi. There we go. Now we know whether or not we're making an input recording. Now here during the init phase, we're going to check if we're making an input recording, then we're going to allocate special memory for it. So where is appvars? Take me to that. File am I in? Forward CPP? Great. What we're going to do here yeah, I feel like this could almost be eliminated soon, actually. How should I do this? So the options are what? Put it in appvars, put it in the models. What's the difference? There's no difference. The only difference is you have to, yeah, okay. So let's go to fored, or app target actually. Yeah, as I suspected, this is not including the simulation events yet. So fored input simulations needs to get included in here somewhere. This depends on nothing but the defined, so let's just put this all the way up at this level here. Fored input simulation event.h, and then what we're going to do is we're going to go here and we're going to one second, this frame count. Okay. So this is going to be right here, the simulation events array, and the recorded event count. And what we're going to do is during app init, init recording, if settings if models settings dot make input recording, then what we're going to do is system memory allocate max recorded event max allocate max times the size of a simulation event. I'm going to set the initial max to be 4 kilobytes of memory. And then it's just a matter of models recorded events equals simulation event putter, models recorded event count equals 0, and max equals max. Alright? How does that build? Good. Then what I want to do is I want to be able to say app read command, set up memory, app read command line nonsense. Alright, this is a good place to do it. App recording emit events. Here's the system functions, here's models, here are new events and new event count. And what we want to do is check that we can fit the new events. So if models event count recorded event count plus new event count is less than or equal to models recorded event max. Well, let's do if that's greater than it. Then what we want to do is we want to go void star new putter equals, we'll take new max equals 2 times the current max 2 times the current count plus the new event count. That's the right one to do. And then system memory allocate standard growable array style thing. So simulation event, there's the new putter, mem move into the new putter from the model's recorded events by the size of one of these, which is, yeah, I'll do it this way, one of these times the count, and then we can memory free the recorded events. Now this raises the question in my head, does memory free, yeah, requires a size. So I need to take the size of this again times the recorded event max. And then finally we can take this equal to the new putter, and we can take event max equal to the new max. Marsalix, evening. So that hopefully is good. What have you got for me? Any bugs? Any compilation time bug catching? Alright. Me and my compiler are on the same page still. Now I want to go down to app step. You know what I never did was I never did the clipboard. Pasting things onto the clipboard isn't handled in the scripts yet. It's not even handled in the data format yet. Yeah. Ah, interesting. Well, that'll have to go on to the to-do list. Stop it. Support clipboard events and in forid and foris. There we go. Alright, now what we want is emit recorded events. We're going to do this right here. Every frame, yeah. We are going to say if the model's settings record, wait, what is it? Make input recording. Then what we'll do is we'll say, okay, we need to prepare to make some input events. Now what is the total number of input events that could happen in one frame, right? Well, there's the array count on the key input data. There we go. Okay. So there's those events there. And then, in addition to those events, we can have a mouse move event, 4 different, like, we can't press and release in the same frame. So I guess two different events, one for left and right mouse, the wheel, the mouse position, right? So again, that's those position, wheel, left, right, and exit. Okay. So now what we want to do is, we're making an input recording, we want to look at input, and we want to work out what all these things need to look like. So, for instance, if input is trying to kill, then we need to put that into the events. So simulation event new event equals new events plus new event counter plus plus new event, and at each step we should probably assert that this is still less than this, and then the new event, we need to just set the type equal to, for all of these, what we need to be able to do is say, what is our counter index for this frame? We don't know. The type is going to be a simulation event exit, and that's it. Okay, so that's an example of what this stuff will look like. What are some other things I have to do? Let's try to get the keyboard stuff. So key input data for either 2i equals 0, I is less than, input key, key input data, not sure why this is here. Yeah, okay. I'm gonna get rid of that. Application step input keys. So it's going to be keys dot count plus plus I to do. I'm going to do that in just a minute. Can I get the list of all of these locations? Boom, boom. Okay. Boom. So that needs to be the same as that. And then you can go away. And then boom. Next. Next. Jeez. Next. 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 There we go. Now, back to not nonsense. Okay. So, I want to get the key event data. Here what's going to happen is I'm going to grab a new event, then the new event counter index will equal counter index, and the new event type will equal simulation event key, and then key event data will tell me everything else I need to know. Alright, so what does the simulation event look like then? Code modifier, so new event key code equals key dot key code, new event modifiers that's coming in like that. I have to convert it, so let me get flags, where the flags will be modifier flags will be initially 0, and then we'll just do some ifs. So actually I have a macro for this, don't I? If true, no, is this in the test builder? If true, if false, that's what I'm looking for. Yeah. define modifier flag read, and then we will have modifier, these are the flag versions, and so the only issue here is like these are shift, that's command, and that's command, so they're not the same, but that's fine. And the way this will work is like this. I go else if key dot modifiers in if I, well, actually I don't even need that because I could use multiples of these, so I just do modifier flags or equals the f, and that's the whole thing actually. So modifier flag read, and unfortunately that means we can't get these out from the input data. No, we can. That's right. They're just not being preserved is what's happening. Interesting. Interesting. That won't quite work with caps lock. I'll have to think about what to do about that. Really the problem is that the data format we're using doesn't even allow me to specify that, so I would need to just expand out the flags there to have caps lock in it. But the other problem that that will present is, does it give me, this is giving me the key after applying caps lock to it, but if I'm simulating that, would I think it would work. Alright. So none is not one we have to do. Control, modifier control index, modifier alt index, modifier command index. Let's line these up to be nice and pretty. Modifier shift index. So it's going to take the indexes to the flags, right? And then we can put that out right there. Okay, let's see. Key.modifiers. Alright. I'm going to take a quick break. Don't have cookies this time, but I would like to fill up my water and maybe get something else to snack on for a minute. Won't be too long, but let me leave you. Well, you know what? I'm gonna just break the stream off here and resume in a few minutes when I get back. So hang tight.